it's time to leave the coffee behind and get back to the stage for our next session. Well, from the ground, from the road to the sky, from 4 founders to more than 800 people around the globe in just 7 years. That's really impressive. And we will now get to know more about that story and more about how it feels and what it takes as a startup to enter one of the most regulated industries of the world. It's the success story of Lilium. And we welcome on stage the co-founder and vice president product, Patrick Nathen.
In the future, we cannot rely on two-dimensional mobility solutions only. We must seek for the third dimension to solve our mobility problems. How can startups enable the transformation towards sustainable aerospace? Before we can answer this question of the how, maybe we should start, first of all, with the why. Why should startups actually try to enter one of the most regulated areas that is existing? And at the beginning, we started with this why, and we saw a big problem. It is human mobility, and it's a planetary problem. By 2050, it is expected that 80% of the world population will live in suprametropolitan areas. What this will lead to is, it will bring our cities completely to a halt. People living in suprametropolitan areas have a human right, mobility, moving from point A to point B. And since we are relying on two-dimensional solutions so far, what will happen is we get more and more cars in the city centers, and ultimately, we will increase even more the CO2 emissions, and we will see very soon, for the first time in humankind, also collateral damages in these cities, like scarcity of water. Further, all of this comes at a cost. Infrastructure. When you're in 2 dimensions, you need infrastructure. But we can see it all in Berlin, in Munich. It takes decades to implement ground-based mobility solutions. We pay billions and billions for it. And once it is paid off and is implemented, the solution doesn't even suffice the actual demand for which it was built in the first place. This was the why we have started this. These are my co-founders, and that's me. I'm Patrick. Please don't be confused by style, hair, etc. This is really me. And we have started with this why. And now, before we can actually start how we are making this reality and speak about the implementation of a new means of mobility, we need to speak about the what. What is the solution to that? Well, 8 years ago, before we even founded the company, we started with this scribble. This is literally one of the very first drawings that we made and pointed down, we have written down, hey, this is what we want to bring to the market, our solution to this problem, to this planetary scale problem. We thought about an aircraft that can take off vertically. Why vertically? We can access city centers and the periphery around suprametropolitan areas much more easily. We want it to be fast, we want to have high range, and that is the requirement to make it also a profitable business. Ultimately, what we also need is we need to be very low noise. This is an amplifier to be accessible to go into into city centers, but also in these peripheral areas. 8 years later, and with the help of the smartest people in the world, that's our solution, the what, the thing that we will bring to the market. It is our interpretation of building radically better ways of moving. I want to introduce to you the Lilium jet. It is a vertical takeoff and landing jet. So it takes off like a helicopter, vertically, and then moves smoothly into a very efficient forward flight. We have 0 operating emissions because from scratch we have designed an electric powertrain system. Due to this ducted fan architecture, I will say a few words about this later, we have an extremely low noise profile, and we have high and leading capacity for payload. Aside from accessibility, it is really important to speak also about affordability. Having high payload and having a technology at the base that allows to scale this aircraft up is key for this success. Last but not least, it must be safe. We have heard it earlier already. Commercial aviation is one of the most regulated areas. This is good. We are certifying this aircraft to the same standards like the A380 with which you fly from here to Thailand. And more importantly, this solution that we have designed is inevitable. It will come. 8 years ago, when we started the whole thing, it wasn't a question of if it will ever come. Why do we need this? Right now, we see a complete shift of that. People know it will come, and we will transform aviation into a new area. Transportation as a whole contributes already 30% to the global carbon emission. And implementing technologies like that will support us for a greener world. We have talked about earlier a little bit about infrastructure and why it is so important. Well, if you think about one of the key KPIs of this aircraft, having this vertical takeoff and landing, this will actually allow us to leverage a network effect. We can implement what we call vertiports pretty much everywhere where we want. They have a super small infrastructure impact. On a financial basis, it's actually 1% compared to regular infrastructure costs that you have. And what you get with that is, for example, time savings that are substantial compared to existing technologies. I took the example of Munich Airport to Nuremberg. Right now, it takes approximately 2 hours to get there. With the Lilium jet, it will take you approximately 27 minutes. Taking everything into account, first mile, last mile, this gives you approximately time saving of an hour. I mentioned already this word platform. The most important thing is this shouldn't be a single-trick pony. So the technology that we are developing is actually something that will, at the market entry, something that is already adaptable. So we're looking at a business jet cabin that has extremely low vibration and will be piloted with a commercial pilot. But at the same time, the same cabin is designed and engineered such that we can already implement it as a shuttle service with up to 6 people. And at one point, also, we could enable cargo flights. But that's not even the end. Now, we have talked a lot about the why and the what. But now let's come finally to the core essence of this talk, the how we're going to make this reality. And the first thing for that is the technology, what we call ducted electric vectored thrust. From the beginning, when we started this, we wanted to have ducted fans. Why ducted fans? They are aerodynamically much more efficient, and in the design, you have much more choices to design the whole system at an extreme low noise level. Further, when you have ducted fans, you can go into 2 directions. You can have big ducted fans, like 1 or 3, 4 around the aircraft. But what we thought about is we must be efficient at speed and in range. And therefore, what we decided for is we dissect these huge fans and make a lot of them and distribute them equally around an airframe. Why would we do that? We can make aerodynamic surfaces, such as rudders, tails, and ailerons, we can make them obsolete, and therefore have an extremely integrated and very efficient overall system. I'm very happy also to say that we're breaking several records with this kind of a system. A single motor can produce a normal operation without a problem 100 kilowatts on a system that's not even weighing 4 kilograms. We're doing this to aerospace standards with our suppliers, Honeywell and Denso. All talk, rendering, where are you? When is it coming? Actually, this technology is right now being tested in Spain. We have moved our testing team, our approximately 50 engineers, manufacturing engineers, over to Spain to gradually expand the flight envelope of this aircraft, and everything that we're doing there is conformant with the normal processes that you can see in an aerospace company. What you can see here is our 5-seater technology demonstrator, one of his test flights. What you can see was this vertical takeoff, and now you will see this gradual moving forwards. No ailerons, no rudders, no tails. What I think is remarkably about that, aside from these beautiful olive trees all over there, is it's its first of its kind aircraft being built for the very first time by a completely newly assembled team in a completely new environment. Something like that has not been yet existing. Just recently, we reached a milestone. We finally came to the point where we have merged transition. What is transition? Transition is the point between the vertical flight and the forward flight. And what you can see here is quite unexciting, right? Nothing is happening, nothing is shaking, nothing is like where you say, oh, I don't want to sit inside of that. That is the work from the engineers back there in Westling. We have incredible capabilities to predict how the aircraft will behave, and it does it exactly like we do it. This takes tremendous efforts, and it's not recognized in the slightest what it takes to do something like that. What you will see now in a second is how the aircraft is basically coming back. It is the same effect like flying forward. You will see the so-called back transition of the aircraft. And maybe one or two words why we're doing this at all in Spain. Well, stable weather. We are located in Munich, and it's extremely difficult to have constant, very good weather conditions to conduct flight tests. In Spain, we are able to conduct multiple flight tests per week, even per day. And the wine is better. So, this is basically the second part of how we are enabling it. We have the technology, now we have tested the technology, and we're doing this continuously, but we also need to certify it, the third pillar. Certifying it is the biggest and the hardest thing in aerospace. We are having a quite different approach compared to our competitors. We certify the aircraft under the eagle eyes of the European regulatory bodies, but also the American bodies. So we're certifying for EASA as well as for the FAA. And this takes tremendous efforts within our company. Frankly speaking, we need to test and develop a lot. It is hardware. We are a startup, 4 people, now over 800, in a startup environment, and we're building hardware, which is already extremely hard, therefore the name. But also, it is aerospace. It is extremely hard to be successful there. And therefore, we're doing all the efforts necessary to make this a reality. We have over 50 test engineers who are working on a more than 3,500 square feet big production hall, and they're conducting hundreds of tests in all systems, subsystems, integration tests, functional testing for this aircraft. And we're also conducting multiple wind tunnel tests of this aircraft to get everything to our understanding how the aircraft will behave, such that we are successful down the road in certifying the aircraft. What you can see here is a little summary of all the tests that we're a little bit conducting. On the top left, you can see one of our very first flights, which is a little bit wobbly. What we did, we took the learning out of it, and we're actually capable of modifying our flight control laws. We were refining the model, and now we have the stable flights that we've seen earlier. On the top in the middle, you can see how we are destroying, or try to destroy, materials that we want to implement inside of the aircraft. On the right, you can see bird strike testing without the birds. It's just still called bird strike testing that we need to conduct. On the lower left, you can see control allocation tests. And one thing I was missing the whole time, particularly, there's another pillar needed, and that is one thing that got always into in our way, where the batteries. And what you can see on the top bottom there is one of our tests where we wanted, on purpose, to destroy a thing, a cell, to understand how it really behaves. It's not only about the normal operation, it's also understanding how failures are behaving. And over the past years, and I mean years, we have been working with ZenLab and custom cells together to get the battery that we need in order to sustain and support the business case that we're having. I mentioned this earlier, we have this very short takeoff and vertical takeoff, and this very efficient forward flight. And actually, the cells that we have developed, co-developed with our partners, are the ones that are giving us the high power demands for the short takeoff and landing, but also the high energy density that we require for the long-range flight. And right now, at the PDR where we are, we can confirm a range that gives us 250 kilometers physical range, what the aircraft can fly, but also 175 operational range, considering all the reserves that are required to bring the aircraft ultimately into service. Now, we talked about technology, testing, certification, and battery. 4 pillars. One pillar, or basically the roof above all of this, is missing. It's the team. It's the biggest privilege in the world to work with over 800 people who are smarter than you, who can rock absolutely everything out of the way to make this a reality. And this team of over 800 people, they're not even anymore Lilians, they're visionaries. And these are the people who make this not anymore render, but bring it to service in 2025. Thank you.
Patrick, thank you very much for sharing all these insights with us. And as I mentioned, this is an interactive event. So are there any questions from you guys? Any questions for Patrick? I just wanted to let you know that I'm really impressed by the whole story for many years now. So if you need any people for test drives, I'm just around the corner in Munich.
You have a license?
I would also, no, I don't. I'm just just offering. I would also come to Spain, not for the wine, but for you guys, honestly. No, you talked about, Patrick, as we don't have any questions, obviously, here from our audience. We do have, perfect. Go ahead. We bring a microphone to your place.
I'm interested in who the consumer is, who's buying this, or how does somebody purchase a ride in one?
Yeah, perfect. Very good question. So we follow a 3-layer model. So at the very beginning, we won't be able, because it's aerospace, to drop thousands and thousands of aircraft immediately and create network on our own. So we will start with private ownership and fractional ownership with airline partners together to basically get the aircraft on the market, to test it with the consumer. We are having multiple partners already selected with whom we are bringing this aircraft actually into service in fractional ownership as well as in private ownership. And then over the years, when the real, let's say, the B2C customer is coming, we know really how the aircraft will work in service and how we can deploy it and actually then bring the network effect really to scale. To the last point, actually, we have commitments with Ferrovial in Florida where we want to build for approximately $250 million a network over the next years. So that is basically the approach. It's a little bit what Larry Page said about the first Tesla. It is an horrible car, but it's great technology. And in the same way, we see we need to refine basically this approach to go to the market. First, individual customers basically, and then load it out to everybody.
Hello, my name is Bernhard from German Reality Institute, Abu Dhabi. So my question is, the CDR, when you expect that?
CDR is expected next year.
And second question, what is, in your opinion, the biggest challenge at the moment in your approval to get?
In the prototype?
Your EASA approval, what is your biggest challenge?
EASA is actually working with us extremely together on all matters. Shall it be means of compliances, requirements, regulatory, basic, but also the operational part. So we're having a very strong connection, both EASA and FAA. The biggest challenge is actually much more organizationally. When you build, we are still, I would still say we are a startup, but it's extremely difficult to be fast in an aerospace environment. And what we are following is the approach of the org must follow the product. The product is driven also by the timelines that we have and that we must fulfill. We are not there yet, right? Everything that I said is not 100% locked in. We need to be fast, we need to be efficient, and we need to bring an aircraft in time, in safety, with the right safety metrics on the market. And therefore, designing the organization that allows basically a startup mindset in aerospace is what I would say the biggest challenge. And you always need to reflect on this.
Yeah, very nice. Thank you.
Absolutely. I think we had another question in the last row.
Hey, Patrick, it's Jason from AWS. Quick question for you. If you take a city, I don't know, like New York, London, cities that are experiencing big congestion, you used a use case of kind of inter-city hopping. How do you imagine it being used inside a city? Is it short trips? Is it?
Yeah, that's my personal opinion here also right now. I'm not a big fan of that because it will amplify the original problem. Because the problem is that too many people are way too much congested, living in congested areas. The idea must be, how can we get people, while having the same mobility ways, out of these super congested areas? How can you live, I don't know, Boston, for example, or like near Boston, or around New Jersey, for example, and then always fly with much less time invest, actually, to New York City, in the city. So this approach, basically being able to live and work wherever you want, even like, let's take out this whole environment of Corona right now. This is something that cannot be solved by intra-city flights. And therefore, I'm not a huge fan, but that's my personal opinion about that.
So I think the most important goal should be for you to come very fast from the city of Munich to the airport.
Yeah.
Patrick, thank you very much so far from the audience, but not from me, because I have a final question for you. I'm always asking myself, if there are so many fishes in the ocean, like in your kind of field, there are so many companies working on the same topic, try to develop and develop kinds of eVTOLs. Is that for you personally and as a company more a challenge or more a chance?
It's the biggest chance that we have. Imagine we would be the only ones. Where's the market pressure? Also in terms of fundraising, if we would be the only ones with a kind of an idea, nobody would even expect that there's actually a market. So having different competitors, also with different models and different aircraft architectures out there, understanding that this is a severe problem that needs to be solved, helps on all kinds of ways. Not only having business pressure to be on time, it helps in fundraising. More importantly, it also helps with the regulatory bodies. Because coming in the moment when we are standing in front of the regulatory bodies, we're all the same, we're not competitors anymore, because we're all envisioning to actually bring these kind of technologies to reality. So it's actually a really good chance.
Absolutely. And I think on top, it's also like being in sports. You run much slower if there's nobody chasing you.
Exactly.
Patrick, thank you so much.
Thank you so much.